You probably heard that the cloud is just someone else's computer. And it's true to an extent. But that computer isn't just any old machine. It's a powerful server running multiple workloads, each isolated, secure, and efficient, thanks to virtualization. In this session, you will explore how virtualization has revolutionized modern IT, from virtual machines to lightweight containers, all running on hypervisors that act as the engine of this transformation. Let's start with the basics. A server is a powerful computer designed to provide services, resources, or data to other computers, often called clients, over a network. You might be running a web app, storing files, hosting databases, or managing identities. These tasks are served by a physical or virtual server. Modern server infrastructure is rarely one server, one task. Instead, you virtualize. A virtual machine lets you emulate a full physical computer entirely through software. You get your own virtual CPU, memory, disk, and operating system, giving you the flexibility of a traditional machine without needing physical hardware. When you deploy a VM in Azure, you're essentially renting an isolated portion of a powerful physical server. You choose the operating system, whether it's Windows or Linux, and select the right size based on how much CPU, memory, and storage you need. From there, you manage it just like a regular server. One of the biggest benefits you gain from using VMs is full isolation. Your virtual machine runs independently from others on the same host, which enhances both security and stability. If you are supporting legacy applications, VMs are a great fit. They allow you to run older systems in a modern environment without changing the app itself. You also get the freedom to work with any operating system. Whether your workload runs best on Linux, Windows, or something more specialized, VMs give you full control over the OS layer. Managing your infrastructure becomes more flexible too. You can easily take snapshots, back up your virtual machines, or even migrate them across regions or environments without disrupting your workloads. Just keep in mind, VMs come with some overhead. Each one runs its own full OS, which makes them heavier compared to newer options like containers. But for many scenarios, especially those needing full control, VMs remain a powerful and reliable choice. This is where containers truly shine. Instead of virtualizing the entire hardware stack like virtual machines do, you virtualize just the operating system. You can think of containers as lightweight, self-contained mini apps. Each one includes everything it needs to run, such as code, runtime, libraries, and dependencies. But they all share the same underlying OS kernel, which makes them fast and efficient. You'll notice how lightweight and quick to launch containers are. They start up almost instantly, making them ideal for high-speed development cycles, responsive microservices, and auto-scaling environments. You save both time and resources with minimal overhead. One of the key advantages you'll appreciate is fast deployment. Since containers include everything your app needs and share the host OS, you can spin them up in seconds. This speed is invaluable in dynamic environments where agility matters. You also benefit from a small footprint. Containers don't include a full OS like VMs do, which keeps their size tiny and resource usage low. That means more containers can run on a single machine, improving efficiency and reducing costs. Another major plus is portability across environments. Whether you're moving between dev, test, and production, or even between on-prem and cloud, you can rely on containers to behave the same way. That consistency helps you avoid the "it worked on my machine" problem. Finally, containers are excellent for automation and CI/CD pipelines. You can easily integrate them into your build, test, and deployment workflows, helping you ship faster and with fewer bugs. Automation thrives in containerized environments. And remember, You don't install Windows or Linux inside a container. Instead, you run your container on a host OS, either Windows or Linux, leveraging its kernel while keeping everything else neatly packaged. To run virtual machines or containers, you need something powerful working behind the scenes, a hypervisor. This is the software layer that sits between your physical hardware and the virtual environments you create. It's what makes virtualization possible by allowing multiple systems to share the same physical resources while staying isolated from one another. There are two types of hypervisors you should understand. The first is type 1, also known as a bare metal hypervisor. You install it directly on the physical server without needing a host operating system. Because it has direct access to hardware, it offers the best performance and efficiency. You will see this type used in large enterprise environments and cloud platforms. Common examples include Microsoft Hyper-V, VMware ESXi, and XEN. The second type is Type 2, or a hosted hypervisor. This one runs on top of an existing operating system, just like any other application. It's perfect when you're working in development or test environments on your own laptop or desktop. Tools like VMware Workstation and VirtualBox fall into this category. While they're not as performance optimized as Type 1, they're incredibly useful for everyday virtualization tasks in smaller setups. When you work in cloud platforms like Azure, you're benefiting from Type 1 hypervisors behind the scenes. These ensure that virtual machines and containers are isolated, secure, and run efficiently across multiple tenants, giving you the performance and reliability you expect from enterprise-grade infrastructure. Choosing between virtual machines and containers depends on your needs, and you'll make that decision based on control, compatibility, and efficiency. You will choose virtual machines when you need full OS level control. With VMs, you manage the entire operating system, allowing you to configure security settings, install system-wide software, and run applications that require a specific OS version. If you're dealing with legacy software, VMs are the right choice. These older applications often depend on specific OS configurations or traditional system components that containers aren't designed to handle. When compliance and isolation are critical, especially in industries like finance or healthcare, VMs give you strong boundaries between workloads. Each VM runs in its own sandboxed environment, which helps you meet strict regulatory requirements. You'll prefer containers when you're building and deploying microservices. Containers are perfect for breaking applications into smaller, independently deployable services that can be managed and scaled separately. If you are looking for fast and portable workloads, containers offer unbeatable startup speed and flexibility. You can run them consistently across development, test, and production environments, or even move them across cloud providers with ease. When you want to maximize resource efficiency, containers shine. They use far fewer system resources than VMs, allowing you to pack more workloads on the same hardware and reduce operational costs. In real world environments, many organizations actually run containers inside VMs. This hybrid approach gives you the scalability and speed of containers with the added isolation and control of VMs, bringing together the best of both worlds. When you work with Azure, virtualization becomes incredibly simple and flexible. You don't have to worry about physical hardware or complex setup. Azure takes care of that for you. If you need a traditional server, Azure Virtual Machines give you fully managed infrastructure as a service that you can customize with your choice of OS size and configuration. For lightweight, fast deploying solutions, Azure Container Instances let you run containers without managing any virtual machines or orchestration layers. It's a great choice when you need to spin up isolated workloads quickly and cost effectively. When you're ready to manage containerized applications at scale, Azure Kubernetes Service gives you the full power of Kubernetes orchestration with built-in monitoring, scaling, and lifecycle management. And if you're developing web apps, Azure App Service offers a streamlined way to deploy them in a containerized environment, ideal for fast builds and continuous integration workflows. With Azure, your job is to focus on the workload and innovation. Azure takes care of the underlying hardware, hypervisor, and platform operations so you can move faster and stay efficient. So, what's your key takeaway? As you wrap up this topic, remember that servers are the foundation of everything you build in the cloud. When you need strong isolation and full control over the operating system, virtual machines are your go to solution. If you are looking for speed, efficiency, and the ability to move workloads across environments seamlessly, containers offer the agility you need. Behind it all, hypervisors are the brains enabling this virtualization magic. And with Azure, you get the flexibility to mix and match VMs, containers, and orchestration tools to fit your workload perfectly. You focus on building, Azure takes care of the rest.